Hi students, today we will be learning more about quadratic functions and how to use a table to find the different points on a quadratic function, and also reviewing a little bit more about the vertex, which we learned about last week. So let's start with an example with a table. So here the function is x squared, and there's the x values. We need to put each x value into x squared to get f of x. Remember, f of x is the same thing as y, so we put 1 into the function. F of x, or f of 1, equals to 1 squared. We put a parenthesis every time we see an x, and then we put the value inside. So it's 1. So what is 1 squared? If you need a calculator, if you need help, feel free to grab that. 1 squared is 1. And so we know that when the x value is 1, the y value, or f of x, is equal to 1. We do the same thing for 2, 3, and 4. So 2 squared is 4, 3 squared is 9, and 4 squared is 16. And that's how we complete the table. Alright, let's try another example. In this example, there are two terms for f of r. So in f of r, there's r squared and 2r. So we need to write f of parentheses equals parentheses square plus 2 parentheses. Every time you see the variable, you change it to a parentheses so you can put your r value in, depending on what it is. Start with -2, put -2 inside the parentheses. So f of -2 equals -2 squared plus 2 times -2. And then we solve for it. Once again, if you want to use your calculator, you can, or you can just solve. -2 times -2 is 4. Positive 2 times -2 is -4. Then we have 4 minus 4, which is equal to 0. So when r is -2, f of r equals 0. Now let's try it on the calculator. So we could put parentheses -1 squared plus 2 parentheses 1. Same thing as what we did when we write it, but you could just type it in your calculator. So same thing for 0. 0 squared plus 2 times 0 equals 0, and 1 squared plus 2 times 1. So we'll have the terms -1, 0, and 3. For -1, f of r is -1. For 0, f of r is 0. And for 1, f of r is 3. Alright, let's do one more example on how to complete the table. So same thing, but this one has 3 different terms. So f parentheses, replace the a with just parentheses square, plus parentheses, plus 1. So for whatever value of a, we put it inside the parentheses. So -2 right now will replace the value of a. F of -2, -2 squared, plus -2 plus 1. And when we solve that, -2 squared is 4 plus -2, that will be minus -2, and then plus 1. So 4 minus 2 plus 1. 4 minus 2 is 2, and then 2 plus 1 is 3. So when a is -2, f of a is 3. Once again, we can use the calculator, type it in to find the answers as well, like parentheses -2 square plus parentheses -2 plus 1, and it will get the same thing, 3. If you like, there's also one more way to do this. You could use Desmos graphing calculator and type the whole function in. So you can type f parentheses a. We normally call this f of a in English. So we could type f of a equals a squared plus a plus 1. Then you can look at the graph and look for each value. So when a is 0, what is f of a? So when a is 0, f of a is 1. What about at 2? So when a is 2, f of a is 7. And what about 4? We'll have to scroll higher. When a is 4, then f of a is 21. So instead of having to look at the graph to find each point, Desmos has a really cool feature. There's a Edit List button up here. It's a little circle. click on that, then click on the table icon. You can fill out that table to get whatever points you need to complete the table for your problem. So we want -2, 0, 2, and 4. We just type those in. We could even put other numbers if we like, or we could just leave it blank, and we will find all the y values, or the f of a. Just remember, because this is a, in Desmos they may use x and y or different variables, but it will be the same thing. Okay, now let's review a little bit about what we learned last week. You might remember this page. We're going to focus on the vertex. The vertex is the point where the graph changes direction, and we use x, y, the coordinate points, to represent the vertex. All right, let's try a problem. So here, where does the graph change direction? Well, right there at 0, 0, or the origin. So all we need to do is write in the vertex for the x value and the y value. X value is 0, y value is 0, 0, 0. Now this graph is a bit different, and just a reminder, for each x value, if there's more than one y value, it is not a function. So please remember that this is not a function. But still, we can find the vertex because it is still a parabola, and all we need to think about is where is the point where the graph changes direction. And we can see that point is right there. It is at 2 for the x value and 5 for the y value. So the point 25 is the vertex of this graph. Now, what do we do if we're only given an equation and we're asked to find the vertex? Well, there's two ways. Last week we saw the equation of a graph in vertex form. So it's y equals a, parentheses x minus h, squared plus k. H is the x value for the vertex, and k is the y value for the vertex. So with those two numbers, we can find the vertex. So let's take a look at this example. Y equals 6x squared plus 4. Let's put a parentheses around the x minus something squared plus 4. K is easy here. We can easily see that k is 4. So we know that that is our y value for the vertex. It's 4. But what is that number h after the x? What is it subtracting? It's 0. Because there's no number, we know that it's subtracted by 0. Let's take a look at the second example. What is the h value? It is 7. What is the k value? It is 1. So our vertex is 7, 1. Just be very careful. Remember that for the h value, it's x minus h, and if there's a minus sign there, that number will be positive. But for the k value, it's plus k in the original equation. So if there's a minus sign there, the number will be negative. Likewise, if it is x plus 7, your 7 would have been negative. So please be very careful with your positive and negative signs. Also, if you do get very confused, you can always use the Desmos graphing calculator. You can just type in the equation of the parabola into your graphing calculator, and once the parabola is graphed, just take a look at the graph. Where does it change direction? Where is the point that the graph changes direction? And that is the vertex, similar to what you did when you solved it with a graph. But now you can just use Desmos to create the graph and then find the vertex. Both the equation method and the graphing method on Desmos will get you the same answer.